Good morning. I am Shayan Khakmardan and I want to present new approach to minerals production project. New approach to minerals production abbreviated to PHRS. PHRS is a novel process to giving value to metallurgical and mining byproducts. This versatile process can recover valuable elements from metallurgical byproducts, mine tailings, and wastes. Here we focus on copper anodic slime. This process consists of different pyrometallurgical and hydrometallurgical processes, which can convert smelters to a multi-metal production plants, which is necessary for special elements in special locations, for example, strategic minerals for European Union. In one word, PHRS will improve efficiency of metallurgical production and recycling. Also, it ensures safety and environmental and economy. How it works. Usual smelters, after taking copper concentrate as input, they will produce a copper anode, and then after the electro-refining process, they will have a copper cathode to sell it to the markets. Then they will have another byproduct named copper anodic slime, which is full of gold, silver, selenium, tellurium, platinum group metals such as palladium, and also copper and nickel. This material usually sold directly to market and not pre-processed in smelters. Here with PHRS we try to separate and recover all the metals, all the precious and minor metals in the plant and turn the copper smelters here to a multi-metal production plants. This process is not just a scientific achievement, it's an industrial alternative to current expensive and polluting processes. We applied this process for zinc oxide and lead oxide production plants to minimize coal consumption. As you see, PHRS is using pyrometallurgical and hydrometallurgical processes which is created by our group. PHRS can produce different products, different elements from copper anodic slime. As you see, we can produce tellurium oxide, gold, silver, platinum group concentrate, selenium, rhenium, and copper sulfate. In compared to other processes, there are two different processes. Pyrometallurgical processes, which is no longer in use for copper anodic slime. They are very bad because not recovery of tellurium and selenium, and they just emit them into the atmosphere, and they have a high environmental impact because these elements are so toxic. These processes are old and so expensive. By the way, pyrometallurgical process kind of it used for copper production, and it is 80% of a year. On the other hand, we have hydrometallurgical process. This process is a low recovery for some elements, a low environmental impact, but not completely safe, and hard to operate. For copper production, it has just 20%, but for copper anodic slime, it's about 100%. Conversely, here we have PHRS. With PHRS, we can recover all valued elements with minimum environmental impact, and it is safe, cheap, easy to operate. And the revenue is high, and the kinetic is medium, and it's new. What we have here is the environmental friendly, multi-product support, and user-friendly and safe. This process is designed and developed by top industrial and academic professionals. A sample flowsheet of PHRS. After we take copper anodic slime as an input, we put it in PHRS reactor. It will give us minor metals concentrates. Then we need to purify it. After that, the residue go to PHRS leaching plant. Then we can extract and recover precious metals. And finally, we will have a residue which go back to the smelter. this residue has a high amount of copper, and it can be an alternative and also an additive to the smelter. Where can we apply this process? We can use PHRS on different copper smelters around the world, such as Norwanda, Glencore, Atlantic Copper, Kazink, Nisico, Nyrstar, Nexa, and others. Also, recycling companies such as Umicore and Metallo can have a benefit of this process because it adds byproducts to their and new products to their companies. Intellectual property of this process is 100% for myself, but the prototype patents for the hydrometallurgical and the pyrometallurgical is different. In the hydrometallurgical patent is 51% for myself, 25% for American University of Technology, and 24% for Professor Bahram Rezai. On the other hand, the pyrometallurgical patent is owned by Sormak Mine Company when I was there as R&D manager. This process needs to be registered as a new patent. The initial scientific team was Professor Bahram Rezai with more than 175 journal papers and 180 conference papers and more than 8 patents, with more than 20 years of experience in mineral and metallurgical field. On the other hand, we have Ali Akbar Abdullahzadeh. He is also professor of Amir Kabir University of Technology with more than 80 journal and conference papers and 1 patent. He is very professional in modelizing and simulation of the processes. And I, Shayan Khakmardan, I am former R&D manager of Sormak Mine Company, which developed several processes for base metals productions, zinc, lead, and also copper. I have papers and patents and applied these processes in the industry. I research on top universities and institutes around the world, from Kazakhstan, Bosnia and Herzegovina, Iran, Belgium, France, and Germany. This process created in Amir Kabir University of Technology, also called Tehran Polytechnic, which is one of the top universities in Iran and also Middle East. Then this process well developed in Sormak Mine Company, which is a very well-known base metals company in the Asia. These are some of my achievements, and I hope we can have a safe industry and we can use the resources economically to retrieve strategic elements. Thank you for your attention.